Okay, moving on to chapter 1.2. These first two problems are to remember what to do with our negative exponents. We have a rule that says, any base to a negative exponent, you can rewrite it as 1 over b to the n. So the base moves, and only the base, by the way, and then the sign of the exponent changes. Works the other way. If you have 1 over b to the negative n, then it's making the exponent positive. It's just moving it to the numerator. Okay. All right. So on this one, it's 1 over 5 squared, which reduces to, or which we can calculate to 1 over 25. A note, I think, and let me know as you work, I think that XYZ homework will let you enter either one of those, but let me know. Okay, so we have a rule that says we can apply that exponent to both the numerator and the denominator. So that's going to look like this. I'm giving myself a little bit of room. 2 to the negative 3 over 3 to the negative 3. Okay, but we really didn't have to do that, because if you understand how this works, basically the numerator is going to go to the denominator with a positive exponent, and the same with the denominator. It's going to go to the numerator. So really the next step is going to be 3 to the third over 2 to the third, which simplifies to 3 to the third is 27, 2 to the third is 8. Again, I'm thinking you can enter either one of those with the positive exponents, but let me know. Okay, a little bit more challenging. So we have this exponent outside of all this multiplication, and we can apply that exponent just like we did with the division. We apply it to all the multiplication. Again, I'm spelling this out to make it really clear. Actually, that's a negative 2, so probably the best thing to do is to drop everything to the denominator. So I get a negative 3 squared. We get x squared squared and y to the third squared. All right. We're going to do as many calculations as we can and simplifying. So our power rule, some base to the n and m, is we multiply. Okay. So we've got negative 3 squared is 9. X squared squared is 2 times 2 is 4, so x to the 4th, and 3 times 2 is 6, y to the 6th. Okay, we've got things going on in both the numerator and the denominator. First thing I have to do is apply that outside exponent, though. So 3 to the third, x to the third is x to the 9th, y to the third, and then again x to the third in the denominator, and y 2 times 3 to the 6th in the denominator. And we're going to put together our x and y's. So if we have the same base with different exponents, then we can do subtraction. Be careful with the order you do your subtraction in. It has to be the numerator, and why did I write it wrong? It has to be the numerator exponent minus the denominator exponent. All right, so this will simplify. 3 to the third is 27. X to the 9th divided by x to the third, 9 minus 3 is 6. And y to the third divided by y to the 6th. That means that I could say 3 minus 6 and get a negative 3 in the numerator, but I know I'm going to have to drop it down to the denominator. So it's as though we're doing that in, upside down here. So I'm just going to subtract the denominator from the numerator exponent and leave it in the denominator. And we are done. All right, I'm going to stop this video, and I will see you on the next video for the next example.